Hi everyone, let's continue with one more example of similar type. Before learning this kind of questions, I would like to recommend you to watch previous recordings where I explain you how to design DFA for substring A or AB or ABB. In addition to this string ending with A or AB or ABB. These 6 videos are prerequisite to understand this kind of question. Let's learn now how to design DFA to accept all the strings with TOC as a substring. Letters will be the same, CHARIOT. What's the meaning of this? Try to identify the condition and understand it. Condition says that here sigma will be these letters. For example, CHARIOT. Sigma consists of these letters, these symbols. Our automata will be reading all these 7 symbols, but accepting the string where TOC is present. That's the condition. So here minimum length string will be, we should have the TOC as a substring. But substring means what? TOC should be present. Before this TOC, any symbol may come or may not come. May not mean 0 or many times. After reading the TOC, any symbol can come. It may or may not come. May or may not means 0 or many times. It may come or may not come. Now start designing once we understood the condition and writing the MLS, minimum length string set. Our first state is Q0. First string is TOC. Always design DFA for the main condition, minimum length string set, TOC. So Q0 reading the T. One state read one symbol at a time. So reading T. T should not get accepted, hence Q1 is a non-final. Next symbol is O. Q1 reading O. Going to another state, Q2. Next symbol is C. TOC, R substring. So transition for this C should go to the final state. So Q3 becomes final. TOC is accepted. Now as usual, once our condition gets satisfied, try to make automata deterministic. How to make it? Same uniform method. From Q0 there is a transition for T. But transition for other symbols CHARIO are missing. Only transition for T. So I will write the same thing. Target state is Q0. How to reach to Q0 from starting state? How to reach to final state from Q0? Starting Q0 same, so nothing will come here. Q0 to final, I need to read the TOC. Same method. Q0 to final, I need to read TOC. At Q0, I need to find transition for C, H, A, I, R, O. So Q0 reading all these 6 symbols. After reading the 6 symbols, Q0 will be reading TOC. What I mean to say here, I can write the same way. See, single C may come before TOC, double C may come, triple C may come, or no C may come. That is what? 0 or many. So before reading TOC at Q0, 0 or many C's are coming. 0 or many means what? Self loop. For which symbol? At this moment C. Similarly, before reading TOC, single H may come. Before reading this TOC, single H may come. 2H or multiple H or no H means epsilon. Means TOC, before TOC, 0 or many H may come. 0 or many means what? Self loop. So H also having self loop. Similarly, A may come 0 or many times, I, R, O. All these 6 symbols may come 0 or many times. Because after reading these symbols, our main string TOC is present. So all are valid strings. Hence I am writing here self loop for all these symbols. C, H, A, R, I, O. This is a label for this self loop. Before reading TOC, any symbol may come 0 or many times. That I have explained in the MLS also. Before TOC, any symbol may not come 0 or many times. That I have written here. Now Q0 is deterministic. Why? Because from the Q0 there are 7 paths, 7 transition for all the symbols given in the sigma. Here sigma is given indirectly. Sigma consists of letters of the word CHARIOT. Now let's make Q1 deterministic. Same way, how to reach to Q1 from starting state? By reading T. How to reach to final state from the Q1? By reading OC. Now For what we are looking transition here? I'm looking transition for C, I'm looking transition for H, I'm looking transition for A or I or T, because transition for O is already there. Again 6. In this case, we don't know whether this string is valid or invalid at this moment, because see TCOC, first string, if I take TCOC, we don't know is this valid. At this moment it is not, but as usual in the last few examples I explain you, after reading the first T, I'm trying to find transition for C. I don't know what will be the next symbol. Initially this is invalid, but we can make it valid because we need to consider all possible positive scenarios, because after reading the C, if TOC is coming, then this becomes valid and it should go to the final state because TOC is present. Similarly, if I take the H, same thing. So for the first few symbols I will be explaining you like this, how to find transition for C. At which state? State is Q1. So write down here. I am trying to find transition for C from the state Q1. So transition for C from the state Q1 will go to some other state. That some other state will read the TOC, or from that some other state there will be a path for TOC which will go to final state. Why? Because this TC TOC, this is the valid string, it contains TOC as a substring. So by reading this string, it should go to the final state. Hence, automata saying that transition from Q1 for the symbol C will go to some other state. That other state will read the TOC. From that other state, there will be path for the TOC which will go to the final state. So which is the state here which will read the TOC? Check here Q0, Q1, Q2, Q3. Which is the state? Check for the Q0. Is there any path from Q0 for TOC? TOC going to final. That's what we are looking. So here other state is nothing but Q0. So transition from Q1 for the symbol C will go to Q0, and from Q0 there is a path for TOC. So transition from Q1 for symbol C which will go to Q0, and from there path for TOC is there. Similarly, I can take for H. If I write here H, see TH TOC. At this moment Q1 is trying to find transition for H, but after reading H, what is the next symbol? We don't know. But we need to consider all the positive possible cases, because if it's valid string, it should get accepted. If it's invalid, it's okay, it will not get accepted, but valid should go to the final state. Hence I am making the invalid string valid. After reading the T, finding for H, and directly writing here TOC, because by considering H I cannot write TOC, so I am writing here TOC directly. So how to read this? Q1 is trying to find transition for H, and this transition will go to some other state. From that state there is a path for TOC. So what is it? Q1 is trying to find transition for H. So which is the state from which path for TOC? Same scenario, it's the Q0. So transition from Q1 for symbol H will be connected to the Q0. So I am writing here H. So there is a path for CHO. Now let's repeat the same for A also. Let me write here A and let me explain to you. Same scenario. See, TA invalid, make it valid by writing TOC. Q1 trying to find transition for A, going to some other state from where path for TOC. So which is the state? There is a path for TOC, it's a Q0. So again I am connecting this label here CHA. Same I will be repeating for R. Try to write down here R. I am trying to find transition for R from the state Q1 which will go to some other state having path TOC to the final state. It's a Q0 only. So I am writing here R also. Next one is I. So I am writing here I. It means what? Q1 is trying to find transition for I. It will go to some other state from where there is a path for TOC, and this will go to final. Initially if I take here I, this string becomes invalid, but I need to consider positive possible cases. I am making it valid. So it is Q0 only. So I am writing here I. Next one is T. So I am writing here T. So I'm trying to find transition for T from Q1. In this case, TT and again TOC. So as I mentioned in the previous video also, if already T is coming, you only need to consider OC. So let me rewrite this to explain in another way. I'm trying to find transition for T. From which state? From the Q1 state. Transition for T. How to reach to Q1? By reading T. How to reach to final state? By reading OC. Now, why am I taking this OC here? You may get confused again. In the previous cases, I have not taken, but in this case, I am taking. Why? Because if T is coming here, is this your valid string? Yes. In previous cases, it was not becoming valid case. If you see here, see TCOC or THOC or TAOC are not valid initially. Later on, by writing TOC, I made it as valid. But in this case, by writing this T, reaching to final by reading OC, it becomes valid. So I'm considering this case. Q1 looking for single T or double T is also allowed. Double T also allowed because OC as it is. Again TOC is there. If triple T is coming, OC as it is. Again TOC is coming. If suppose starting to Q1 T as it is, Q1 to final OC as it is. If no T is coming means what? Epsilon. Epsilon contains 0 number of symbols. It means what? Q1 looking for 1T or double T or triple T. Also Q1 looking for 0 number of T. 0 number of T's means I can write like this. 1, 2, 3, 100 T means what? Many T. So Q1 looking for 0 or many T's. It means what? As we know, whenever there is a 0 or many, we need to give the self loop. At which state? Q1. So Q1 will have the self loop. For which symbol? Symbol is T. Now from Q1 there are 7 paths, 7 transitions for each symbol of the CHARIOT. 1, this 2 and this 5, 7. Now Q1 is deterministic. Similarly, we can make Q2 as deterministic. You can follow the similar kind of approach. So how to make Q2 deterministic? Write down the Q2 first. For which symbol you are looking transition, write it. So Q2 I have written here. How to reach to Q2? By reading TO. See, Q0 to Q1, Q1 to Q2, TO. How to reach to Q3? By reading C. Now I am trying to find path here. For which symbol? Already there is a symbol C is covered from Q2. So other than C, what are those? H, A, R, I, O, T. So for all these symbols, I need to find the path from Q2. Now, if you see this initially, all are invalid. TOHC, invalid. It does not contain TOC. TOAC, if you are not able to understand, you can write like this. TOTO means for each state. Are these valid strings? No, these are not valid. We need to make it valid. Reason why? Because we are trying to find transition for these symbols. After this symbol, what will come we don't know. As one state read one symbol at a time. By reading this symbol, what's the next symbol? No one knows, neither state, neither automata. So we need to consider all the positive possible cases. How to make it? How to reach to Q2? By reading TO. I am trying to find transition for H. I am taking the first case, TOH. Is this valid? No. Make it as a valid, because if it valid string, it should go to the final state. So how to make it valid? I want TOC. By considering the existing symbols, can I make TOC? No, because H is there. So I am directly writing here TOC completely. Is this valid? Yes. How to read this? Q2 is trying to find transition for symbol H. Q2 is trying to find transition for symbol H. This transition will go to some other state. That other state will read this TOC, or that other state will have path for TOC, which will go to final. Why? Because TOH, TOC, this is a valid string. After reading valid string, automata should go to the final state. Hence, transition from Q2 for symbol H should go to the some other state which will read the TOC. Again you have question then, what is the state which will have the path for TOC going to final? We have Q0, Q1, Q2, Q3. So which is the state having path for TOC going to final? Check for the Q0. Q0 having the path TOC. So here other state is nothing but Q0. It means transition from the Q2 for symbol H will go to Q0, and from Q0 there will be path for TOC. So I am writing this here in this way. So this is for H. Similarly, I can take for A. If I write here A, initially it's not valid string. How to make it valid? Write down TOC here. Then here also what is there? It's a A. It means what? Transition for A from Q2 will go to some other state. From that state there is a path for TOC which will go to final. It's a Q0 only. So here after H there is possibility of A. Similarly, if you study it, if you do it, same case for R also. Because after these all symbols, I don't know what's the next symbol, but TOC may come. We need to consider the positive case. And this positive case transition should go to the final state. Okay. So what are the other symbols? H is covered, A is covered. For R, same. See, up to this, it's the same. For last case, I will explain to you. But H is covered, A is covered. For R, TOC may come. For I, TOC may come. For O, TOC may come. So all these transitions from Q2 will connect to some other state which will read the TOC and go to final. So what are those? H, A is covered, then R, then I, then O. What's remaining now? Remaining is T. Why I left this T? If you remember, I explained in this video previously as well as in the previous video. When I want to make condition like this, how to reach to Q2? By reading TO. I am trying to find transition for T. Is this valid? No. I am trying to find transition from Q2 for symbol T. But this is not valid. We can make it valid with the help of existing one. Here TOH, TOC is not possible, so I have written completely new TOC. But in this case T is present, so I need to only write OC to make it as a valid. So TO, TOC. So Q2 is trying to read transition for T. I am writing here like this. Q2 is trying to find transition for T, which will go to some other state. That other state will read the OC and will go to final. You will say why? Because TO, TOC, this is a valid string. Transition for all these valid strings should go to the final state. So Q2 is trying to find transition for T, which will go to some other state. That other state will read the OC, or that other state will have path for OC which will go to final state. Now try to find out this other state which have path for OC. Check from Q0. Q0 have path for OC? No. Going to final? No. Check for Q1. Q1 having path for OC? OC. Going to final? Yes, satisfying both. Having path for OC going to final. So here other state will be Q1. So transition from Q2 for symbol T will go to Q1. So Q2 to Q1 for symbol T. If you want, you can verify. TO, TOC. First symbol is T. Second symbol is O. TOC. Third symbol is T. Again OC going to final. So TO, TOC is accepted as it contains TOC as a substring. Now make Q3 as a substring. It's very easy. How to make Q3 as a substring? You can follow the same approach, or there is a shortcut also. What is the same approach? Write down the Q3. How to reach to Q3 from starting state? By reading TOC. I am at Q3. At Q3 I am trying to find transition for which symbol? I am trying to find transition for C. For all the symbols, because from Q3 there is no path. I am trying to find transition for H, A, R, OT. By reading TOC, I am trying to find transition from Q3 for all these symbols. And these symbol may come or may not come, we don't know. Because if coming, then also our string is valid. If it is not coming, say epsilon, TOC as it is, TOC dot epsilon is TOC. If these symbols are coming 0 times or many times, then also okay, because we already read the TOC to reach to Q3. Hence 0 or many at state Q3. So 0 or many means what? Self loop at state Q3. For which symbol? All these symbols. So how to write all these symbols? So we can write here C, Q3 having self loop for C, or H, or A, or R, or you can say I, or you can say O, or you can say T. So Q3 having self loop for all the symbols, and this is your final DFA to accept all the strings where TOC as a substring. You need to follow the same approach what we have seen in the previous 6 question. A string ends with the A, string ends with the AB, string ends with the ABB, and string contains A as a substring, AB as a substring, ABB as a substring. If you watch these 6 recordings, 6 videos, you will be able to understand this question easily. In the next question, we have one more practice question like IOT as a substring. Thank you for watching.